Hey guys, Travis Gillespie. In the last examples, we have learned to classify real numbers, also uh, classify all numbers. Now we're going to apply something called the density property of real numbers. And I'm going to move off way over here and get a whole clean screen. Well, the density property, it tells me of real numbers states that between any two real numbers is another real number. However, this does not include integers or whole numbers. It only applies to the rational numbers. So let's figure out why that is. I'm going to throw up a number line here. Let's get a green number line. Maybe that'd be cool. Oh, it's blue. Anyway, that will work out still. And on this number line, I've got some values. Oh, I like to throw 0 up a lot because I tell my students to. Sometimes I'm lazy and don't do it, and then I feel bad because I tell them to and then I don't do it. So let's say I have the integers, or let's say I have whole numbers 1, 2, 3, and 4 here, and I can see that I don't have, between the numbers 0 and 1, there's no other whole number, or between the numbers 1 and 2, there's not another whole number. And if I were to create a second number line in this number line, let's throw up the numbers. We'll throw up some negative numbers. Well, I'm still going to throw up a 0 because I tell my students to. And let's say I've got 0, 1, 2, -1, -2. And I can still see with the integers, I forgot an arrow over here, but the integers, also, there is not another integer between -2 and -1. Notice how I'm saying the term integer. And applying the density property of real numbers, stating that there are more numbers between other numbers. If I were to say there are more integers between integers, it doesn't work if I were using the number -1 or 0, 0 and 1. So therefore, the density property does not apply to whole numbers. It does not apply to integers, but it should apply to rational numbers. And there are an infinite amount of rational numbers between rational numbers. So again, to go back to our table for a second, I can show you that the density property will apply to real numbers and rational numbers. However, it will not apply to integers or whole numbers. So theoretically, there are an infinite amount. If I were to draw my third number line, before I do, I'll just explain it here. There are an infinite amount of rational numbers between 0 and 1, or actually an infinite amount of real numbers between the values 0 and 1. Well, let's take an example here. Let's say that I want to find a number that's between 5 and 2/5 and 5 and 3/5. And I'll throw up a number line here to make the visualization a little bit easier. Be through 5 and 3/5. And this will be 5 and 2/5 here. So let's find a number that's between these two numbers. And I'll pull up the screen just so it's a little bit easier to see. Well, how can we do this? The way to do this, I'm going to change our color for a second just so you can see. I'm going to take the average of these two numbers. I'm going to take 5 and 2/5 and add it to 5 and 3/5. And I'll take the average of these two numbers, and that's going to give me a midpoint. That's supposed to be 3. So I know that 5 and 5, 5 plus 5, that equals 10. And 2/5 plus 3/5 actually equals 5/5, which equals 11. 10 plus 1 equals 11. If I were to divide that by 2, so remember, 11 divided by 2, well, final answer is 5 and 1/2. 5 and a half is between 5 and 2/5 and 5 and 3/5. So again, according to the density property, 5 and a half is between 5 and 2/5 and 5 and 3/5. And there are infinitely many numbers between many real numbers. That's my phone going off. So I will end here, but there are infinitely many numbers between any two integers. And I just realized I said integer. There are between any real number, any two real numbers, between any two real numbers, there is another real number. Thank you. Thank you.